All right, so now we're going to review lecture test 3 for fall of semester of 2023. A handful of you noticed the other day that that there were some repeat questions. I think there was about 5 of them. And we pondered on campus what to do about it. New operating system for me, as everyone's well aware of. So I don't really know the ins and outs of it. I tried for a way to compensate, to just remove the questions and make it all work out. And in the end, what ended up happening is you could imagine, I suppose, when you take away 5 questions from a test, that takes away from both sides of the equation. It takes away from the total possible points. And if you got them right, it also takes away from the earned points. So you guys may have seen some of your numbers shift. It looks from a slightly more than cursory glance, excuse me, that everyone's score, it either stayed the same or went up. I do not believe anybody's score dropped. If you feel that to be the case for you, please see me or email me at some point. So the score was adjusted to 55, and then the bonus point. Online folks, I don't think I went through and graded the bonus question yet for you guys, but I did grade it for the on-campus folks. I will do that, promise. So 55 possible points, total points with a possible of an additional bonus point, extra credit question there. So everyone's score should be adjusted. All right, questions. Process that breaks down materials at the surface of the earth into smaller pieces. So breaking down of material we call what, you guys? Weathering. Good. And just a heads up, you're starting to, many of you fret about the final. Weathering, erosion, deposition, sediments, all those vocabulary words you are definitely going to see again. All right, it is a geology class, and that is the root of geology. So if you miss these first handful of questions, asterisk them in your notes, okay? Because you are going to see these again in 2 weeks. So weathering. Transportation of said broken down materials we call erosion. Awesome. When we stop moving stuff, when we put it down, you make a what at the bank? Stop your money from moving around. You make a deposit, deposition. All right, so putting down sediments is depositing them. It's essentially the end of erosion, or at least a temporary stop. At least a temporary stop. What do we call those broken down bits and pieces? Come on, you guys. You got these right. Sediments. Good. Good. And lastly, when we want to glue all those sediments together and turn them into a rock, we call it what? Lithification. Beautiful. Again, plan on seeing every single one of those again on the test. All right, now how do I change pages here? Next page. Hey, good. All right. Sediments can be comprised, made up of, which of the following materials? Can sediments be organic? Yes. Can sediments be inorganic? Yes. So both of those. All right. Plan on seeing this again as well. So we learned boulder, cobble, pebble, sand, silt, clay. That's obviously largest to smallest. What do I ask you for? Oh, I was nice. I asked you for largest to smallest. I often will reverse it, okay? I italicize it, I underline it to make you, if I could make it blink, I would, all right? But, again, maybe on the final, read it carefully because it might be bass backwards, all right? And that would be, that's in here somewhere. Clay, silt, sand, pebble, cobble, boulder. Doesn't quite roll off the tongue that easily as the other one, so. That's why we learned it the other direction. A little more sing-songy. All right, now just some general questions about sedimentary rocks. If they're composed of rock and mineral fragments, are they clastic, chemical, or organic? Or they can't be made of other rocks. Clastic. I heard a vote for clastic. We agree? Yeah. And again, clasts are rock fragments. That's their name. That's their definition of what a clast is. Tricky. Which of the following is not a clastic sedimentary rock? They are all clastic sedimentary rocks. All right, and coming off of the rock test, hopefully that was an easy question for you because that was something we had you memorize for lab. Said rocks composed of bits and pieces of previously living materials. Organical. Very good. Said rocks that grow in water, crystallize from solution. Chemical, the only one that's really left here other than sedimentary rocks don't. All right, a little bit of chemistry. In order to precipitate minerals to grow rocks, the water must first be what? This is maybe a harder one here. We're looking for saturation, okay? Remember, abrasion is breaking down of rock. Deposition is putting down sediment. Lithification is gluing sediment together. So that could be, a question if I was asked. That could be a good answer if I was asking you about the sediment. But we're talking about the water. So what do we have to do to the water? Remember, you had to saturate in order to precipitate. All right? And in case you forgot that word precipitation's in the next question here. Who of these grew? Does halite grow as water evaporates? Yes. Does limestone grow in ocean water? Yes. How about quartzite? Yeah, that's when you bake sandstone. Okay? So A and B. A and B. And we don't really do partial credit. I apologize if you picked like one of the top two, not the other. When you only give 1 point to a question, it's kind of hard to do halfsies. Okay. These are questions here. This one and I think the next one that asks you what mudstone's made out of. I always feel bad when somebody misses these. But also you really ought to be able to sort this out by this point in the semester. We call it sandstone because it's made out of sand. Okay? That's it. That's why. That's cause. Mudstone. And see, if I wanted to be tricky, I would have put like clay and silt in separate answers. And then maybe down below had a all, A and B or something like that. But, I didn't want to be tricky here. I just wanted to really reinforce what we've been talking about. Wet sand is just wet sand, okay? You don't have a name for it. You say, I got wet sand on me. If you step in mud, you don't say, I got wet clay and silt. Wet dirt. Yeah, wet dirt's even different. I'm thinking of like potting soil, But yeah, so anyhow, clay and silt, all right? Clay and silt turn into mud when you get them wet. And wet pebbles are just that. They're wet rocks, right? So mudstone comes from clay and silt. And then lastly, breccia and or conglomerate. All three, okay? And again, Mother Nature knows no sizes, so, if she wanted to make a conglomerate out of boulders, she could. It'd just be a really, really big, hunk of rock. So, if cobble and boulder showed up in there, you could, of course, color those in too as answers. But based on what you saw in lab, based on what we've ever talked about, it is pebble, sand, silt, and clay. But again, she could glue anything she wants to together. All right, application level multiple choice. Good times. What can we assume when we see a layer of coquina in the rock record? Coquina was the rock that was made up of what, you guys?
Shells.
Shells mostly, and some sand, and some, whatever, seaweed, a little bit of plastic here and there. In order to get the seashells, all right, we want to go for beach there. The area was previously covered by an ocean. That would be, limestone, and I'm not sure, maybe that is another question here coming up in a minute. But I really tried to differentiate and stress with you guys, limestone comes from oceans, coquina equals beaches. So I felt that these were, fairly fair questions. I hope you didn't do miserably on them. Bituminous coal, we told you, if you see that layer of coal, it used to be a swamp or a marsh, yeah. All right. Limestone, we were just talking about that. Limestone was covered by the ocean as far as we know. All right. That is the only way you can make limestone is in salt water. And I didn't ask you about the desert one because you could argue either way with a sandstone, but you could argue that it was beach as well if you're far enough back, maybe out of the seashell zone, et cetera, et cetera. So we left that question to scoot free. All right, rock formation stuff. Utica shale, where do you find it? Utica, what's it made out of? Beautiful. So, do we got an option for that? What kind of rock is it? All right. Who first found the layer? Where the rock layer was first found. Yes. So, A and C. Do we have an answer for that? We do. Answer E. And back in the old Scantron days, this would have had to have been one of those A-B answers, right? Because I've got more than your standard 5 choices. So, you guys can rest assured you don't have to color in A-B anymore, because I know that made a handful of you twitch. All right, the Utica shale can be found in Utica and is probably made of shale, or it can be found in New Hampshire and is made of sandstone. Well, we could have named it that, but that would have been rather rude of it. So yeah, generally speaking, this is the case with rocks. When you find a new fossil, that you do get to name after yourself quite frequently, okay? So you'll see when you see some of these really weird names. Sometimes it means something in Latin or Greek, but a lot of times they threw their last name in there just because they could. But rocks, we don't really do that. All right, unconformities, okay? Something's not right in the rock record. There's rocks missing. And it takes a little more investigating to find out why, okay? Could be a whole lot of weathering and erosion, just erased all the rock, moved it somewhere else. Or it could have been a period of non-deposition. Rocks just weren't being made. You could usually tell if you poke around enough. So long periods of time missing from the rock record are unconformities. And here we go. An unconformity in the rock record can be caused by a burrowing animal. Godzilla maybe, but otherwise not so much. A shift to an erosional environment. A shift to a non-depositional environment. Or both of those. And both of those would be good. And I apologize, I probably should have said weathering and erosional environment, but hopefully you didn't get caught up on that one. And again, the one exception to using devices during a test, you can always email me, okay? You're sitting there taking the test. There's a decent chance I might actually get the email while you're taking the test. So those of you who no longer get to take it in class, okay, even though I am sitting here and offer you the opportunity to come take it in class, and then you folks at home, you never know. Shoot me an email. But otherwise, please no phones or computers during the test. Boundary layer between two rock formations we call a contact. the rock layers are the beds, okay? And the contact is in between the bed when it stops being limestone and starts being shale, for example. All right, a gnaw mark on a bunny leg bone would be what?
Trace fossil.
A trace fossil, okay? The gnawing is evidence that there was predation, which is evidence that there was something much larger than bunnies that didn't eat grass in the area, okay? The bunny leg bone itself, which should be the next question, yep, is a fossil, all right? And we gave you some examples of this in class. I showed you that amazing snail video, right? So in class we talked about not only could you find a seashell on the beach, but you could find a seashell with a borehole in the back, and you found two things, right? You found the dead clam, and you found the fact that somebody ate that clam instead of dying of natural causes, as clams sometimes do. But slanted or crossed beds indicate this as a previous environment. So cross bedding. Area was a desert. I happen to be pointing at that one there. And we told you that it could be beach dunes as well, but I asked you not to fret about that and just keep it in one location. But technically speaking, cross beds equals sand dunes. And as you know, sand dunes can be found in the desert or on a shoreline. And sometimes in the middle of Rome, New York, or Albany, New York. I don't know if you guys are aware, we have some sand plains and dunes there. And probably a handful of other places on the planet. It was deposited by the glaciers. But generally speaking, all right, the area was a desert in this scenario. All or part of a plant or animal preserved in the rock record. That there would be a fossil. Fossil. Asymmetrical ripple marks. All right, remember ripple marks came in two sizes, two flavors, I should say. Straight up and down, or pointing in one direction. All right. Straight up and down was symmetrical, and aiming in a direction was asymmetrical. So, directional means water was flowing in one direction. Straight up and down means water flowed back and forth. So water's flowing in one direction, that we call that there a stream. All right. When water flows back and forth, back and forth, back and forth, that is some sort of wave-producing body of water, be it a lake or an ocean. So, what do we got? We got asymmetrical ripple marks. That would be one way. That is a stream. That is a stream. Symmetrical ripple marks, wave-producing waters. And again, we don't want to stereotype and say the ocean or something until we look further. Not sure if you guys have had the opportunity to get up to Lake Ontario, which is your closest Great Lake. And you will definitely get waves there, and you do get ripple marks there. All right. So there are localized, I should say, inland bodies of water that are definitely large enough to produce ripple marks. So you would look, again, for your type of material you're in, so on and so forth. It really is some cool kind of sleuthing that gets to happen there. All right, and this question caused a lot of stress for some folks, but it is a hard question, if that gives you any consolation. It's tricky, all right, but it's a thinker, it's a riddle, if you would. For a series of rocks, it starts with sandstone at the bottom, then has a layer of shale, then igneous rock, then sandstone again. Which of the following statements best describes their age relations? Well, you should always go into this with a superposition in mind. The oldest stuff's on the bottom, the youngest stuff's at the top. All right, we learned that as a general rule. So, generally speaking, you would say they increase in age from the top down. Increase in age from the top down. So that gets older as you go down. All right. However, you got this thing here in the middle. You have an intrusion. Well, we don't know if it's an intrusion. I guess that's the problem. We have igneous rock. And like I said, I was explaining this to someone in class the other day. The first clue is rock name, rock name, and then just rock type. It's real generic. So if it was an intrusion, all we could say was that the potential, because you don't know unless you go in and age date it, you don't know when that intrusion came, other than it had to have intruded in between two layers of rock, right? So shale, then sandstone, the igneous rock would have come in between those. If there was something else on top of the sandstone, you wouldn't know technically if that came before or after the intrusion until you did some age dating stuff. But you know at least that the shale and the sandstone had to be there, if it were an intrusion. If it was a lava flow, because igneous rocks can be both, then it had to go shale, lava, sandstone, because the lava wouldn't go in between rocks layers. So the answer is right here. You could not know unless I told you if it was intrusive or extrusive, if it was an intrusion or if it was a lava flow. So tricky question. And you like to reward people for getting a tricky question right by giving them more points, but then you also penalize the people that get it wrong for missing more points. So even though it was a harder question, it's still worth just 1 point, okay? Because again, you don't want to stick it to the folks that didn't get the question right. So if you got that one right, great job. It's a hard question. If you missed it, don't feel bad. It was a hard question. All right. Here's superposition right here. In an undisturbed section of rock, and I kind of put this here as a clue. Undisturbed section of rock, the oldest rocks are at the bottom, and the youngest rocks are at the top. That there is superposition. Environment extends outward in all directions until it blends into another environment. That is lateral continuity. It continues laterally, outwards. And these are, by the way, the repeaters. In an aquatic environment, sediments are deposited in flat layers. I really couldn't say in horizontal layers, so I had to say flat. But that's original horizontality. Principle that states an igneous intrusion must be younger than the rock it has intruded into. That would be cross-cutting. Cross-cutting. All right, done with that stuff apparently. Going into solution. Remember, coming out of solution was precipitating. Going into solution is dissolving. So, dissolving... shows up as an answer, okay. But it is also chemical weathering. It's both. Dissolving is a type of chemical weathering, and we gave you an option for both B and C, I hope. Yes, we did. It's called E. I just talked about this accidentally. Coming out of solution, we call precipitating. Precipitating. That's when those crystals grow, making sedimentary rocks in water. Frost wedging. Frost wedging we talked about as an example of physical weathering. All right. And it is not what glaciers do. Glaciers are just giant snow plows. All right. Giant snow plows. That would be more like frost nudging or something. I don't know. But no. So this one just has one answer. Abrasion is a type of physical weathering. And abrasion causes rounding. And we talked about that a little bit in class. That's how you get those rough edges off, by abrading something. It's rolling back and forth in the water. Usually is the best way to do it. Your streams, it's really hard to pick up an angular rock in a stream or in an ocean because it's been rolling around, banging into other rocks. And a lot of people think it's the water. The water is simply responsible for moving it around. It's hitting those other rocks that breaks off those sharp edges and so on and so forth. All right, we didn't really talk about this in class, but it certainly was implied, all right? Weathering and erosion help each other out. The agents often work together, okay? And we've, I think, just conversationally given you several examples of how that is true. In fact, I just did. Speaking of the agents, wind, water, ice, and gravity. What do we got? We got gravity, we got ice, we got wind. Who's missing? I think water's missing. Wait a minute, is this another repeat? What effect, if any, can physical weathering have on chemical weathering? Decreases, increase, have no effect on one another. Oh, that is a separate question. My bad. I assumed this was that question we just snuck up on. We also didn't necessarily talk about this class. It was pretty much implied. But physical weathering can help chemical weathering. Think about any time you try to dissolve something, right? They, generally speaking, don't give you a giant, hockey puck size thing to dissolve in water. You get powder, all right, or you get tiny pieces, parts. So physical weathering can certainly help chemical weathering move along. It's all about surface area, The more that you could expose to, more surfaces you could expose to the water or whatever, will allow it to happen faster. So, a related question then, I suppose. I don't know that I need both of these. What effect can physical weathering have on chemical? It can help increase it. All right, that is essentially the same question, just worded differently. Our token metamorphism questions. Had to do a couple. We did spend some time talking about it. So, only high temperatures. That's baking the rock. That gives us a non-foliated. Remember, foliation comes from pressure, comes from movement, generally tectonic activity. So if you're just heating it up, that's the sandstone growing into quartzite. That's the limestone turning into marble. Handful of others. Bituminous to anthracite. High temperatures and pressures, well, that's when we start moving stuff around. That's foliation. And again, you will probably see these very generic questions again on the final. It is a geology class. I have to ask you about rocks, right? So, or at least making rocks. Oh, okay. So this is about bake zones, which we touched on with igneous intrusions, but also reminded you during our metamorphic rock conversation. Basically speaking, all this is asking you is, what does limestone turn into? Limestone turns into marble. If I had this intruding into a shale, what answer would you have picked? Slate, okay. If I had it intruding into sandstone, you would have picked quartzite, so on and so forth. In reality, is it that simple? There's a little more to it. But, again, this is a 100 level class. We're teaching you guys the gist of things. You're certainly not going to make it nice, though. Okay, winding things down finally. Philosophy that implies that the processes occurring today occurred in the past at similar rates. What do you guys call that? Uniformitarianism, yes, sir. Rapid changes are responsible for the earth as we know it. I keep inadvertently highlighting the answer. Catastrophism. Except in this case, it landed on a made-up word. Philosophy that implies it's slow and steady as well as catastrophes. Actualism, what actually happened. All right, now, again, application. If you believe in uniformitarianism and you look out your window, can that have happened very quickly or over a long period of time? You're supposed to say over a long period of time, regardless of what you may or may not believe. All right. That was sort of, again, the very beginning, the foundations of, hey, things need to be a whole lot older than we currently believe that they are. Some more dating stuff here. Looking at rocks comparatively without using numbers. And I did it again. I highlighted the answer. Relative. Looking at time by using numbers. Absolute. Yeah. All right. When dating a sedimentary rock, you will receive a variety of dates. This could be attributed or attributed to which of the following principles? Cross-cutting, uniformitarianism, inclusions, or lateral continuity? Inclusions, yeah. Another kind of toughie. I remember sedimentary rocks are made up of a whole bunch of different things thrown together. And the best you'll ever be able to do is say it is no older than this and no younger than that. All right? You're going to get a wide range of ages. Probably as many times as you sample it, you'll get numbers. Different numbers. Oh, good Lord. Let's see here. You were looking at a cliff face and observed multiple layers of shale and limestone, repeating over and over again, with a granitic intrusion running diagonally through it, presumably all of it. What could a scientist assume? The series of shale and limestone is older than the granite, or the granite is younger than the limestone? Series of shale and limestone is younger than the granite. Which one was there first? That was a weird question weird answers. The intrusion is cutting through rock. What was there first, the rock or the intrusion? The rock, all right? So the shale and limestone were there first. The shale and limestone are older. And this is principle of intrusions, basically, we're asking you about. Oh, there we go. I'm sorry, there was no principle of inclusions. Principle of inclusions, that's the sedimentary rock. This is cross-cutting relationships. My bad. All right, you could safely make the assumption in the previous question because of cross-cutting relationships. You can't cut through a field if it isn't there. All right? Very straightforward. And finally, one simple, hopefully you weren't seriously fretting about the half-life stuff. Wait a minute, where's the question about... Okay, we do have a couple more pages. Or a couple more questions. How many half-lives occurred if you started with 12 uranium atoms and you now have 3 uranium atoms? So one half-life goes from 12 to 6. Second half-life goes from 6 to 3. So we started at 12, we went down to 3. So that there is 2 half-lives. And I thought we were on the last page. We are not. Now, finally, the last page. If uranium decays to lead, then uranium is the parent and lead is the daughter. All right? Parent makes the daughter. Some of you had this backwards. All right. This must be a 56-point test, not a 55-point test. Otherwise, one question doesn't have any points. I'll have to look at that. Okay, extra credit. I tried to be as decent as I could with this. Some of you were really creative. Some of you totally missed the point. Some of you didn't even bother. The biggest thing here, and again, I italicized it and underlined it. The biggest thing here is that it has to be unique to our period of time. And it can't be a fossil. It has to be a trace fossil. So while some of you, first of all, some of you just, again, missed the trace fossil part and went with a fossil. An endangered species could be significant basically in that you might see it disappear in the next layers. And then we'd know there was an extinction event. And that's kind of cool, but that's not what I'm asking. And it's also not a trace fossil, it's a fossil. Some of you, I'm trying to think of what some of the other good wrong answers were. And I had them in my mind for Tuesday. They're gone by now. Some of you went the super, I won't say easy way, but the super easy way and said, oh, an iPhone, an imprint of an iPhone in the rock. All right, there you go. That is unique to us. Tire tracks, which is kind of cheating. We mentioned that in class, showed it on the board, but still, you remembered what I was talking about, so you got some points there. And then, like I said, there was some really cool stuff that I could have never dreamed up. And like I said, if I could give you a point, I did. All right. But first and foremost, it had to be evidence of our society. Okay. Not an object or a critter. And it had to be unique to now. A deer has been around for, I don't know, 5 million years, 10 million years, a long time. Okay. And a handful of other things. So if you're interested in whether or not you got that extra point, feel free to go to the test online, scroll through, and see if you got that point. There wasn't really comment boxes available. Well, there was, actually, but I don't know that you guys know how to check for comments. So I decided to make just a general comment today. And you folks at home, I did not grade this extra question for you yet. I will. So that's test 3, and I won't lie, okay, you're going to see a lot of this content again on the final, because it's some serious, meat of the course.